I built an AI agent that browses the web like a human. It fills out forms. It clicks through Cloudflare protected pages. It scrapes 100 sites in a row without getting blocked once. And the most important number on the screen right now is this: zero point 0.9. That is its reCAPTCHA version 3 score. The same score a real human gets when they sit down at a real Chrome browser. Stock Playwright scores zero point 0.1. Stock Puppeteer scores zero point 0.1. Even the most popular stealth library on GitHub, undetected-chromedriver, scores between zero point 0.3 and zero point 0.7 on a good day. Zero point 0.9 is server verified. Google's own anti-bot system looked at my agent and said, "This is a human." The thing making that possible is a single open source library called CloakBrowser. 16,000 stars in 3 months. MIT license. Free. Zero subscriptions. And the reason it works has almost nothing to do with what every other stealth tool is doing. Today, I'm going to show you exactly how it works, what to build with it, and the 5 mistakes that will get your agent flagged in under a minute. Stay till the end. The paste ready code is on screen. Here is the thing. Nobody told you when you first tried to scrape a protected site. Every stealth tool you have ever used works at the wrong layer. Playwright Stealth, Puppeteer Extra Stealth, Undetected-chromedriver. They all do the same thing. They inject JavaScript into the page. That JavaScript tries to overwrite navigator.webdriver. It tries to fake navigator.plugins. It tries to hide the headless flag. It is a thin coat of paint over a regular browser. The problem is detection does not happen in JavaScript anymore. Detection happens below JavaScript. Cloudflare and FingerprintJS read the canvas at the pixel level. They read the WebGL renderer string. They read the audio context fingerprint. They read the TLS handshake. They read the timing of every CDP message. The JavaScript fix can lie about navigator.webdriver all it wants. The TLS handshake is still wrong. The canvas hash is still wrong. The CDP traffic is still loud. So your stealth script passes one test and fails the other 5. Every Chrome update breaks half your patches. And you spend more time maintaining the workaround than building the actual scraper. The fix is not more JavaScript. The fix is a different browser. CloakBrowser does something completely different. It is not a library you install on top of Chrome. It is Chrome itself recompiled. The team fogged the Chromium source code and applied 49 patches at the C++ level, not on top of Chrome, inside Chrome. When the browser starts up, the Canvas API is already patched to return slightly noisy pixel data. The WebGL renderer string is already returning a real GPU. The audio context is already returning consistent samples. The TLS fingerprint already matches the JA3 and JA4 signatures of a real Chrome browser. The navigator.webdriver field never gets set to true in the first place. It is not removed. It is never there. The Chrome DevTools protocol traffic that every detector watches for, the additional CDP messages that scream automation, that traffic is gone, not hidden, gone. The 49 patches cover Canvas, WebGL, audio fingerprinting, GPU vendor reporting, hardware concurrency, device memory, screen dimensions, DPI, WebRTC IP leakage, network timing, navigator.webdriver, the window.chrome object, navigator.plugins enumeration, the user agent string, headless mode indicators, and the CDP input behavior. This is why detection systems score it as human. Because at every layer they look at, it is identical to a human's Chrome browser. There is nothing to detect. Here is the part that breaks your brain when you see it for the first time. The setup. 3 lines of code. Pip install CloakBrowser. From CloakBrowser, import launch. Browser equals launch. That is it. The first time you call launch, the patched Chromium binary downloads in the background. About 200 megabytes. It caches locally. Every subsequent run, it just opens. No manual Chromium install. No Selenium driver to manage. No version pinning gymnastics. If you have Playwright code already, the migration is one import change. You replace from playwright.sync_API import, sync_playwright with from CloakBrowser import launch. The rest of your code does not change. Page.goto, page.click, page.fill. Same API, same async variants, same persistent context support. You also get a node version on NPM and a Docker image. The Docker image ships with a built-in CDP server, so you can run CloakBrowser on a remote machine and connect to it from your laptop like a normal Chrome instance. 3 lines of code, 30 seconds. That is the entire onboarding. The fingerprint patches get you past the static checks, but there is a second wall of detection: behavioral analysis. Sites like DataDome and Akamai do not just check what your browser is, they check how it moves. Real humans do not move the mouse in a straight line from point A to point B. Real humans do not type at perfectly consistent intervals. Real humans scroll with acceleration. They overshoot the target. They pause to think. The instant you click a button in exactly 12 milliseconds with zero mouse movement before it, you are flagged. CloakBrowser ships with one flag that fixes all of this. Humanize equals true. When you set that flag, every page.click becomes a Bézier curve mouse path with realistic easing and a small overshoot. Every page.type becomes per character typing, delays with thinking pauses and occasional typos that get self-corrected. Every page dot scroll becomes acceleration, cruise, deceleration with micro steps. There is a careful preset that adds idle micro movements between actions, the way a human's mouse drifts when they are reading. You can tune it further with a config dictionary. Mistype chance, typing delay, idle between duration. One flag flips the entire interaction model from machine to human. This is the layer almost everyone forgets, and it is the layer DataDome catches. There is one more layer: identity permanence. The first time CloakBrowser launches, it picks a random fingerprint seed. That seed determines your GPU vendor, your screen resolution, your hardware concurrency, your device memory, your time zone. If you let it pick a new seed every session, every visit looks like a different machine. Cloudflare's reputation systems flag that as suspicious. The fix is one flag. -- fingerprint equals some number you pick once. From then on, every session uses the same fingerprint, same GPU, same screen, same time zone. To Cloudflare, you look like the same returning user every time. You can also lock individual fields: -- fingerprint, -GPU, -vendor, -- fingerprint, -screen -width, -- fingerprint, -brand to switch the user agent between Chrome, Edge, Opera, and Vivaldi. On Linux, the default is to spoof a Windows fingerprint, because pure Linux desktop signatures are statistically rare on the public web and get scored as suspicious. macOS runs native. Windows runs native. Pair this with a residential proxy. Set geoip equals true, and CloakBrowser will auto-detect the time zone and locale from your proxy's IP address. Now, you are not just a human. You are a specific, consistent, geographically coherent human. Now the receipts. The team ran CloakBrowser against 30 plus production detection systems. Cloudflare Turnstile, FingerprintJS BrowserScan, ShieldSquare, CreepJS, Am I Unique? The reCAPTCHA test page. Here is what the numbers look like. reCAPTCHA version 3 score. Stock Playwright 0.1. CloakBrowser 0.9. Server verified by Google. Cloudflare Turnstile. Stock Playwright fails. CloakBrowser passes. Non-interactive auto-resolve. FingerprintJS. Stock Playwright is detected on the production side. CloakBrowser passes. BrowserScan. Stock Playwright is detected. CloakBrowser scores normal on all 4 checks. Navigator.WebDriver. Stock Playwright reports true. CloakBrowser reports false. Navigator.plugins length. Stock Playwright is 0. CloakBrowser reports 5. Window.Chrome. Stock Playwright is undefined. CloakBrowser presents the full object. User agent string. Stock Playwright reports headless Chrome. CloakBrowser reports Chrome version 146.0. CDP detection. Stock Playwright is caught. CloakBrowser is not. TLS fingerprint. Stock Playwright mismatches. CloakBrowser matches real Chrome on JA3, JA4 and Akamai signatures. 30 out of 30 tests passing. The receipts are real. Now, let me show you exactly what to build with this. We are going to build an AI agent that scrapes 100 protected sites without getting blocked using 3 tools: Claude Code, CloakBrowser, and Browser Use, the open source library that lets a large language model drive a real browser. Step 1. Install. Pip install CloakBrowser Browser Use Anthropic. Step 2. The agent file. 40 lines. From browser_use import agent browser. From CloakBrowser import launch_async. You write an async function that calls launch_async with humanize equals true and a residential proxy. You pass the resulting browser into a browser use agent. You give the agent your Anthropic API key. You write the task in plain English. Go to this URL. Find every product card. Extract the title, price, and image. Click the Next Page button. Repeat until there is no next button. Save to a JSON file. The agent reads the task. It plans. It uses CloakBrowser as the eyes and hands. It uses Claude to decide what to click. Every click goes through a Bézier curve. Every type goes through a humanized keyboard. Every page passes Cloudflare. You can swap browser use for Crawl4AI if you want a pure scraping setup, or stagehand if you are in TypeScript, or LangChain if you want a more general agent. The pattern is the same. CloakBrowser is the browser layer. The LLM is the brain layer. The patched Chromium is the body that does not get caught. Here is the operator level rule almost nobody talks about. Even with perfect fingerprints, your IP is doing half the work of getting you blocked. Data center IPs from AWS, Google Cloud, and Azure are flagged by reputation alone. Cloudflare's IP reputation database knows every cloud range. Even with a 0.9 reCAPTCHA score, a data center IP will get you a soft block. The fix is residential proxies, IPs that belong to actual home internet connections. Pair them with CloakBrowser like this. Launch with proxy equals your residential proxy URL and geoip equals true. The geoip flag tells CloakBrowser to look up the proxy's actual location and auto-set the time zone and the locale to match. Now, your browser fingerprint, your IP, your time zone, and your language all tell the same story. A user from Austin, Texas, using Chrome on Windows at 4 p.m. local time, browsing a US retail site. That is a coherent identity. Coherent identities do not get flagged. Incoherent ones do. Skip the geoip flag, and you will get caught the first time a site checks if your time zone matches your IP. That is a 5-second check. Most detectors run it. 5 mistakes I made so you do not have to. Mistake 1. Using element handle objects instead of selectors. If you call element handle.click instead of page.click, you bypass the humanize patches. The browser sends a raw, instant click with zero mouse motion. DataDome flags it instantly. Always use page.click with a selector string. Always use page.type with a selector. Never use the handle methods. Mistake 2. Using Puppeteer with reCAPTCHA Enterprise. CloakBrowser supports Puppeteer through a separate import path. But Puppeteer sends extra CDP traffic that reCAPTCHA Enterprise specifically watches for. You will get intermittent blocks even with perfect fingerprints. The Playwright integration does not have this problem. Use Playwright. Mistake 3. Default macOS fingerprints on aggressive sites. The macOS fingerprint profile has some statistical inconsistencies that aggressive detection systems catch. The fix is to set dash fingerprint platform equals Windows when you launch. Spoof a Windows machine. It is the most common Chrome environment on the public web, so it is the safest default. Mistake 4. Persistent profile versus incognito storage quota. The default incognito context normalizes the storage quota to look like a real user. But if you switch to a persistent profile, BrowserScan's incognito detection check sometimes flags you. The fix depends on the target. For FingerprintJS, stay incognito. For Cloudflare, use a persistent profile and set fingerprint-storage-quota to 5000. Mistake 5. Missing Linux fonts. Aggressive bots like Kasada and Akamai render emoji on hidden canvases and hash the pixel output. On minimal Linux containers, the emoji do not render correctly. The hash is wrong, and you get flagged. Install fonts Noto color emoji and fonts free font DQ TTF before you run. One apt install command, 10 minutes of debugging saved. Quick honest ask. 90% of people watching this haven't subscribed yet. If this has helped you in your AI journey, please subscribe and support the channel. I make these videos because the AI world moves too fast for most people to keep up, and I want builders like you to stay ahead. One click. It is free. It helps me keep making these. I put everything in this video into a one-page operator playbook. Paste ready agent code. The 5 mistakes with fixes. The full proxy and geoip setup. The fingerprint flag cheat sheet. The Cloudflare versus FingerprintJS versus DataDome decision tree. Comment the word CLOAK below this video, and I will send you the PDF. Huge credit to the Cloak HQ team for building this in the open. 16,000 stars in 3 months. MIT license. Go give the repo a star. The link is in the description. If you want to go deeper on Claude Code, Codex, or building agents that ship, The 4 guides linked below are everything I have learned shipping production agents. I will see you in the next one.